Hey everyone, it's Justin again. In this lesson, you're going to learn all about the centroid of a triangle. You'll also learn what the medians of a triangle are, since they're used to make the centroid. If you like to use different colored pencils or pens while taking notes, this is an especially good lesson to do so. In addition to 3 different colors, you'll also need scissors and a ruler to use after this video is over. So pause the video now so you can collect these materials. By the end of this lesson, you will be able to apply the properties of the centroid to compare lengths and solve for unknowns in a triangle. First, we'll explore how to find the centroid through an activity in your notes template, and then we'll complete one multi-part example problem. Locate the first page of your notes template. It has a link to follow for a visual representation of the centroid. The visual is interactive and allows you to move the vertices of the triangle to see how the centroid changes. There is a graphic organizer with blanks for you to fill in after you explore the visual representation. Take your time on this so you can truly understand what it means to be the centroid. Pause the video now and work through this. Let's check your work with the key before moving on. Go ahead and check your answers now. If you had something wrong, it's really important that you go back to the link for the visual again and explore the idea that you were missing. It's an important skill to be able to reason through things on your own, and doing so will help this stay in your long-term memory. Pause the video so you can do this now. Let's do a little more exploration before completing our example problem. The median of a triangle may be a new concept to you, so let's go through all 3 of the medians for this triangle. Here's one median. Notice how it goes from a vertex and bisects the side opposite to the vertex. Here's another median. Again, going from a vertex and to the middle of the opposite side. And here's the final median. The place where all 3 of these meet is the centroid. There's a special relationship created by the intersection of the centroid with each median. Take a look at this. The centroid breaks the median up into 2 segments, and the segment from the centroid to the vertex is 2 times as long as the segment from the centroid to the opposite side. So, if the segment from the centroid to the vertex is 10 units, then the segment from the centroid to the opposite side is half as big, making it 5 units. If this segment was 8 units, then this one would be twice as big, making it 16 units. We can also think of the segment from the centroid to the side as 1/3 of the entire median. In this example, the entire median going from the vertex to the opposite side is 24. And 8 out of 24 is 1/3. And the segment from the vertex to the centroid is 2/3 of the entire median, since 16 over 24 simplifies to 2/3. These relationships will be very useful in this lesson. And the same relationships exist with the other medians as well. Here's our example for this lesson. It says, given that the point A is the centroid of triangle BCD and DE equals 9, complete each statement below with a numerical value. Let's start by labeling our picture with anything we already know. Can we mark anything congruent due to point A being the centroid? Each median bisects its corresponding side. Now, do we know anything about angle measures here, or right triangles like we did in previous lessons? No, the centroid doesn't specify those types of relationships, like the circumcenter and incenter did in our previous lessons. Let's get started on answering the question. There are 4 parts to this problem. Pause the video and see what you can come up with on your own. Let's see how you did. We need to find the length of BE. Ah, here we go. It has the same length as EC, so it must be 4 units. Next is the length of AC. We learned earlier that this section of the median connecting the vertex to the centroid is twice the length of this segment that connects the centroid to the opposite side. So, doubling 3.2 gives us 6.4. The same logic will apply when finding AF. We have 6.2 for the longer segment, so we take half of that to get the shorter segment. Since half of 6.2 is 3.1, that's our answer for AF. The last part of our example is probably the toughest, and it uses this extra piece of information from the directions. If you weren't able to figure it out earlier, maybe you know a little bit more now. Give it a try once again, or double check your answer from when you tried it earlier. Well, we know that 1/3 of DE will be the length of AE. So what's 1/3 of 9? Or what's 9 divided by 3? Right, 1/3 of 9 is 3. And AD must be twice as long as this. So multiplying 3 times 2 gives us 6. And that's what we needed for the rest of our answer. One more quick reminder here. It is a good idea to make sure that the lengths we got here do actually add up to equal the length of the entire median. And 3 plus 6 does equal 9, so this looks good. This is the end of our example problem, and a great time to pause the video and go back to anything that you'd like to see again. Now you can apply properties of a centroid to solve for unknowns in a triangle. There is a pencil balance activity at the bottom of your current page in your notes template. Complete that next before your practice game. Have fun. I think you'll enjoy it. And I'll see you next time.